Hello, welcome to another of our topics in our chemistry lecture series. We are still on the mole concept, but today we will be looking at calculations involving the mole and mass. Now, I know that the mole concept is a very difficult concept for most students to understand. So I am breaking up the concepts in small portions so that you can get a good grasp of the topic. So today, our objectives will include performing various calculations involving the mole. I will show you some formulas that we will use in our calculations, and we will perform calculations in converting from mass to mole, from mole to mass, and calculations involving percentage composition by mass. Let us begin. In starting our calculation, in converting mass to mole, let us look at a few steps that we will use to assist the process. In step 1, we know how to calculate molar masses from previous lesson. So the first thing we are going to do is to calculate the molar mass. We are going to look at the relationship between mole and mass, which includes your molar mass. So number of moles is equal to mass over molar mass. N equal M, small m, over your capital M. Remember that your moles is in MOL, mole, that is the unit. Mass, your unit is in grams, and molar mass, your unit is in grams per mole. And so the triangle here will assist you in remembering the formula, which will make it very easy when doing our calculations. So moles is equal to mass over molar mass. Let's start our calculation. Now look at example 1. We are going to calculate the number of moles given the following masses. So the first thing we must do is to identify the information that is given in the question. So here you see 2 grams of water. So 2 grams of water is giving us a lot of information. 2 grams is saying that our mass is 2 grams. And of course, having the formula of water, we can work out the molar mass. So our only unknown here is the number of moles. So what do? We write down the formula first. So moles is equal to mass over molar mass. What do we have? We have the mass. And the mass is 2 grams. And remember to always work with your units. 2 grams over the molar mass of water, which is 18. Remember, we worked out the molar masses: 16 for the mass of oxygen and 1 for the mass of hydrogen. But we have 2 of them. So it is 16 plus 2, giving us 18 grams per mole. So from that, we can now look at our calculation. We are going to divide 2 by 18. So 2 divided by 18 will give us a value of 0.11 mole. It is best to have our value to 2 decimal places and not round off too early. So calculate the number of moles given the following mass. This is saying that for a mass of 2 grams of water, we have 0.11 mole. Can you try example 2? What would you get if you calculate the moles of potassium chloride? Let us work it together. N equal M over molar mass. Remember, we are converting mass to moles. So we have mass divided by molar mass to get moles. So you identify that information from the question. And so we have 57 grams of potassium chloride, and the molar mass of potassium chloride is 39 for potassium plus 35.5 for chlorine. And that should give you a molar mass of 74.5 grams per mole. And so we'll divide 57 grams by 74.5 grams per mole. So 57 divided by 74.5 is equal to 0.77. Remember, we say that we are going to use 2 decimal places for our answers. So 0.765, we will round up the 6 to 7, because this number here is equal to 5 or greater, we round up. If it is less than 5, then we will round down by leaving the figure. But because it is 5 or greater, we will round up the 6 to 7. So our answer is 0.77 mole. Let us try a few more. Practice makes perfect. But remember, during the practicing of these questions, make sure you understand the reason why we do what we do. So, in other words, let us have a deep understanding of the concepts and not just doing it for doing its sake. So here we have now 15 grams of aluminum oxide. So we have the mass, and we can calculate the molar mass, so we can find the mole. The mole is the unknown. If you are given worded questions, the first thing to do is to pick out the information that is given and to identify what you want to find. And then you can use appropriate formulas to calculate your value. So here again, mole is equal to mass over molar mass. And the mass is 15 grams. And that is divided by the molar mass of aluminum oxide, which is 102 grams per mole. 27 times 2 for aluminum and 3 times 16, and you would add those values to get 102 grams per mole. So 15 divided by 102. Your answer here now is 0.147. Remember, we want our answers to 2 decimal places. So we have a number here that is greater than 5. So we are going to round up. So our final answer will be 0.15. And that is our answer for the mole that is in 15 grams of aluminum oxide. Let's try one final question for converting mass to mole. Again, we want to find our mole, and we know our mass to be 7.6 grams, so we can write that down, divided by the molar mass of sodium hydroxide. Sodium is 23, plus 16 for oxygen, plus 1 for hydrogen, and that will give us a molar mass of 40 grams per mole. So 7.6 divided by 40. And that is equal to 0.19. So here we have our answer for the number of moles present in 7.6 grams of sodium hydroxide. Now, if we can calculate the moles given the mass and the molar mass, could you calculate the mass M given the moles and molar mass? Let us look at some of these questions. In converting moles to mass, we must realize that we must rearrange our equation. Initially, we knew that moles equal mass over molar mass. But now I want to find mass given moles. So therefore, if moles is equal to mass over molar mass, then mass is equal to moles times molar mass. So here we have our relationship that we are going to use to calculate the mass given the moles. Again, it is wise for us to know how to do or how to calculate molar masses, because that is very important in finding the mass or mole in a given question. So step 1, we would calculate our molar mass, and then we would use the relationship from the equation to calculate the mass. Let us try a few. So now, looking at the question itself, we see that we are given the moles of sodium hydroxide. So, what is the information that we can get from this question? We know the moles. The mass is unknown. That is what we want to find. We want to calculate the mass present in 0.5 mole of sodium hydroxide. And we know that we can calculate the molar mass from the compound sodium hydroxide. So, initially, we knew that moles equal mass over molar mass. But we want mass to be the subject of the formula, so we are going to make M the subject. Therefore, M is equal to moles times molar mass. And so, the moles that we know from the question is 0.5 times the molar mass of sodium hydroxide, which is 40. Now remember to put in our units. So 0.5 moles times 40 grams per mole. So mole would cancel mole, and we would get 0.5 times 40. Our answer must be in grams. Let's calculate this value. 0.5 times 40 is equal to 20. So the mass that is present in 0.5 moles of sodium hydroxide is 20 grams. Let's try example 2. Here, we know that we want to use the relationship mass equal moles times molar mass. So we know the moles to be 0.25 moles, and we know the molar mass of magnesium is 24 grams per mole that we get from the mass number of magnesium. So again, mole will cancel mole. Our answer must be in grams. So 0.25 times 24 is equal to 6. So this value is saying that 0.25 mole of magnesium is present in 6 grams of magnesium. Let's try a few more examples. As we proceed, this should become more and more easier as you understand the concept behind the procedure that we are carrying out here. So, we are given 0.625 moles of oxygen. Remember that oxygen is diatomic, and so we would have 16 times 2 for the molar mass of 32 grams per mole. We want to find the mass, and we're given the mole. Therefore, mass equal moles times molar mass. And our moles here is 0.626 moles times the molar mass of 32 grams per mole. So mole here would cancel mole. Our answer must be in grams. So let's calculate 0.626 times 32 grams per mole. 0.626 times 32 is equal to 20.03. So we'll have 20.03 grams. If they ask for our answers to be to 2 decimal places. Finally, now that we know how to calculate moles to mass or mass to moles, this will come in very handy when we start to look at moles and equations. That will be our next topic. But before we move on to that, there is one more thing that we must complete: the calculation of percentage composition. Let's get to it. Now, the calculation of percentage composition by mass is not a very difficult concept to understand. Let us look at a very simple concept to try and understand what's going on here. Suppose I have some balls, round balls like this. And I have some dots within that mixture. I could find the percentage composition of dots to ball or the percentage composition of balls to dot. So in this case, the percentage composition of dots would be equal to, how many dots do I have? I have 1, 2, 3, 4, 5. So that would be 5 over the total dots plus balls. So that would be 5 plus 1, 2, 3, 4, 5, 6, 7. So 5 over 12 would give me a percentage composition of about 42%. Because I would get 0.42. And then this 0.42 you must multiply by 100 because you want percentage of dots. So suppose you wanted percentage of balls present. Then that would be now 7 over the total of dots plus balls times 100. And so we are going to use that principle in calculating the percentage of a particular element found in a compound or a molecule. So this is the relationship or the formula that we will use. Percentage composition is equal to the total mass of an element present over the molar mass, which is the total mass of the compound, times 100. Let's continue. So if we are to calculate the percentage by mass of sodium and chlorine in sodium chloride, we would need to find the molar mass of sodium chloride. And so the molar mass of sodium chloride would be equal to 23 for sodium plus 35.5 for chlorine. So 23 plus 35.5 should give me a mass of 58.5. So the molar mass here is 58.5. Now we want to find the percentage of sodium present, but we only have one sodium. So the molar mass of sodium present there is 23. So the percentage composition of sodium present in sodium chloride would be equal to sodium over sodium chloride, which is 23 divided by 58.5. And that will be equal to 23 divided by 58.5. So we have 0.393. Let's go with 2 decimal places. So 0.39. Now this value is not in percent. So we want percentage of sodium. So we must multiply this value by 100. And so our answer would be 39%. Now, we can now find the percentage of chlorine in the compound sodium chloride using the same principle. But this time we will have chlorine over sodium chloride times 100. So we know that the percentage by mass of sodium is equal to 39. Since it is out of 100, then we should get a percentage by mass of 61 for chlorine. Let's check to see if we will get that value. So the percentage by mass of chlorine is equal to chlorine over sodium chloride. So that will give us a value of 35.5 divided by 58.5. So this is the mass of chlorine and this is the mass of sodium chloride, and we will times that value by 100. Let's check. 35.5 divided by 58.5 is equal to 0.606. But remember that we are going to use 2 decimal places, so I will round up this 0 to 1 since this number is greater than 5. So our answer is going to be here 0.61. So 0.61 times 100 would be equal to 61%. Now remember we got 39% for sodium. So if percentage by mass is out of 100, 39% plus 61% should equal to 100%. As you can see here, 61 plus 39 is equal to 100%. Now that was a simple one. Let's look at a more complicated compound. For example, sodium sulfate. Now we are going to calculate the percentage by mass of each element present here. Let's look at sodium first. It is very simple if you remember that in order to find the percentage by mass of an element in a compound, we must use the total mass of that element present over the total mass of the compound. So in finding the percentage by mass of sodium, we have 2 sodium atoms present. So that will be 23 times 2 over the total mass. Let's work out the molar mass of sodium sulfate. So the molar mass here would be, for sodium, 23 times 2 plus 32 for sulfur plus 4 times 16. So 2 times 23 would be equal to 46. So we'd have 46 plus 32 for sulfur plus 4 times 16, which is 64, plus 64. So the molar mass of sodium sulfate would be 142. So the percentage of sodium present would be equal to 2 times 23. So that's 46 over 142 times 100. So 46 divided by 142 times 100 is equal to 32%. So we have our answer here to be 32%. So the percentage by mass of sodium present in sodium sulfate is 32%. So the percentage by mass of sodium is equal to 32%. Let's find sulfur. So percentage by mass of sulfur present would be 32 over 142 times 100. That would be equal to 32 divided by 142 equal times 100. So our value here is 22.5. But remember that because we have 5 here or greater, we can round up. So our value for the percentage of sulfur present will be equal to 23%. And for the percentage of oxygen present in the compound sodium sulfate, that would be 4 times 16, which is 64 over 142 times 100. That will be equal to 64 divided by 142 times 100 is equal to 45%. Again, because it is percentage, they should all add up to 100. Let's check. 32 plus 23 plus 45 is equal to 100%. So we calculated the percentage of sodium in sodium sulfate, sulfur in sodium sulfate, and the percentage of oxygen in sodium sulfate, and they all add up to 100. So to recap, we did calculations involving the conversion of moles to mass and calculations involving the conversion of mass to moles. And then we did calculations involving working out the percentage mass of various elements present in a compound.